Okay, we're going to look at these fundamental identities. Okay, first of all, I'm going to start off with these definitions of sine theta and cosine theta and tangent theta. So back to this is by definition. This is referring back to the unit circle. Sine theta is y, cosine theta is x, and tangent theta is y over x. Okay, that's by definition. Now, cosecant theta is 1 over y, secant theta is 1 over x, and cotangent theta is x over y. So, I mean, there's a lot of memory involved with math, obviously. So you have to remember those things. But these lead to certain identities. Okay, you can see that tangent theta is equal to what? Well, since tangent is y over x, and you just look at this. Sine theta is y, cosine theta is x. So this is going to give us sine theta over cosine theta. And cosecant is 1 over y, but y is sine theta. What else do we have? We have cotangent. Let me not do that one. I'll do this one over here. Secant theta is 1 over x, and x is cosine theta. Cotangent theta is x over y, so that will be cosine theta over sine theta. But we also can see that cotangent theta is equal to I know the answer. I'm just trying to understand whether I'm supposed to write that somewhere else. I think maybe I am, but I'm going to write this anyway. Right here. That cotangent theta is equal to 1 over tan theta. That might have another name for identities, but that's certainly true. Because you can just see that these two are reciprocals of each other. Okay, there's this thing that someone told me about, is that the cos don't go. I'm not sure if I should put that thing there, the apostrophe. Okay, but the cos don't go. Cosecant does not go with cosine. Cosecant does not go with cotangent. The cos don't go. Maybe like this. The cos don't go. They do not go. The cosecant does not go with the cosine. So, for example, given sine of theta equals negative 5 over 13, and cosine theta equals negative 12 over 13, find tangent theta. And so the solution is tan theta equals sine theta divided by cosine theta. So this is going to be negative 5 over 13 over negative 12 over 13. If we multiply the top and bottom by 13, we get 5/12. Should be able to do that without a calculator. Try another example. Simplify. Secant theta over tangent theta. Well, the idea of simplifying is never really that clear. I mean, sometimes it is, but in this case, what exactly is that about? Simplifying what? Okay, well, what I'm going to do is I'm going to write this as secant theta times 1 over tan theta. And okay, well. So this is going to be 1 over cosine theta times 1 over sine theta over cosine theta. And so that's on the denominator. So what I'm going to, this guy's in the denominator, so I'm going to write this as cosine theta over sine theta. And those cancel out. That gives 1 over sine theta, which is cosecant theta. So, yeah, there's busy work like that. It's sort of fun, though. So we're going to simplify this. So this is equal to sine theta over cosine theta times cosine theta. So that's equal to sine theta. So that simplifies that way. Okay, sorry. So we're simplifying tangent theta, cosine theta. So that's sine theta over cosine theta times cosine theta. Those cancel out, gives sine theta.